Welcome to the interview. In the next 45 minutes, could you help us design Google Drive, a cloud storage system for the users to store files?
Yeah, sounds good. So the goal today is to design a cloud storage similar to Google Drive. So
Yes.
I guess first I would like to go through what kind of requirements we have here. Oops. What are the maybe the core API we are going to look into today? I assume there will be upload file, download file, maybe you can help elaborate more and fill in the detail here. So I would imagine maybe we need to share the file with someone else, or like
Right. Yeah. So primarily, this will support a user to store files in the cloud and from multiple devices, so that the idea is if they go to a different device, they can see the set of files on that device as well. So ideally, we can create some type of mounted drive or directory in the user's client, either the mobile client or the computer client, and then whatever file we put in will show up everywhere when from the devices where the user connects to the cloud, to the Google Drive service. And then sharing is not in real life. We probably can enable sharing, but for the sake of the interview, we don't need to do the sharing.
I see. So we need to upload file, download file, and maybe view a directory, and we need to synchronize file between devices. Sharing between users, that's out of scope. So how about like maybe we have different version of a file? Do we care about that? Like
we can just have the latest version.
Just latest version.
Right.
I said, look over to you, like, the functional requirement, like the core, I guess functionalities that our drive will provide.
Yeah, looks good to me.
Sounds good. Let's think about maybe non-functional requirement. Maybe how many users we will have.
We can assume we have 50 million signed up users and probably like 10 million daily active users.
How about their, maybe read-write pattern? Like what's their typical, like how many files do they typically upload per day? And also like, what's the average file size? And
how many uploads per day? So we can assume maybe 2 uploads per day, 2 new files per day. Although initially the user may have a bunch of files, but in terms of creating new files, we can say like 2 files per day. And then total, we can say for each user, we can provide 10 gigabytes of space for them to store the files.
I see. So it's like, oh, I see. per user. How about reads? Well, how many reads do we expect, like for each user?
So that probably depends. So from the user perspective, they do not actively create those requests to read. So it will be a system design in terms of, so for a user, the expectation is if I create a file in this mounted directory, I should be able to see from the other computers. If I modify something, then I should also see the changes from other computers. Regarding so they don't explicitly click the upload button.
I see. Makes sense. So it's like synchronizing is more important, and it's not like we read the file multiple times. Say if there is no modification, we probably just do the download once, and then the file is there on the device like forever.
Right. Yeah, that would be a reasonable optimization.
So we really care about sync. So talking about like the we then definitely need to make sure the system is highly available. Maybe 5 nines. We definitely make sure the system is reliable. We cannot do we really need to make sure, because we are storage, we need to make sure we don't have data loss. Scalability. To me, it sounds like the write is not a lot, and the read, I mean, we need to download the file once, and the file can be there forever. And I guess it's more about like the network bandwidth. We need to have high throughput.
So your audio seems to be fading in and fading out. Sometimes it's clear, sometimes it's a little bit distant.
I see. I'm just using my computer speaker.
Okay, yeah, I can still hear you. Yeah, that's fine.
You can. Okay, I see. Do you think, is there anything we should consider here, like other than these?
So that looks good. Let's see. Yeah, that looks good. Yeah, anything else you want to consider, or?
I guess that's like roughly what I had so far.
Okay.
So talking about the API, I would assume like we'll have a so what I think is like clients. They will have the client device. Maybe it's a mobile phone or a desktop or anything, and what we'll have is like some client agent process that's responsible for doing all the upload and managing of the local file directory, and then we'll go to some API gateway that's like the front end of our service. Talking about the concrete API, what I'm thinking is like, we have upload file. This is what the client agent will do. Upload file, download file, and also get file directory. It's like, we just have the full, directory of, one user. So download file, we specify the concrete file, and also we don't want to, download all the file, a full file at once, because we don't know the size. What we usually do in a file system is we have, blocks. So basically, this will all be, transparent to the client. The client agent will do all that. When we say we need to upload the file, the client agent will, divide it into, multiple blocks, and we know the file ID, and we also know the block ID, and the client agent will take care of all of these, and these are the API between the client agent and our API gateway.
Okay, sounds good. So for this API design, how does the client agent know the file ID? If it's a file that exists locally, then I imagine we can know the file exists. But if they, from the download side, the file may not exist in the remote computer yet. So how would they be able to call the download file API?
I see. So I think it's like a communication between, so maybe not file ID, it's more like, just file path. Maybe that makes more sense because for each file directory, we know how it looks like, starting from a root directory, and then you have the path to some of the concrete file. So each file you can identify it by the file, a sequence of paths to the directory the file exists in, and then the file name.
Okay, so what is the result of the get file directory?
So it's like the structure of the file passes under the user. So it's like root and blah blah blah. Just overall the structure, how things should look like. I guess initially it will just be a root directory. As we upload more files, and
Okay.
there will be more stuff under there.
Okay, sounds good.
And because say if you set up this on a new device, of course you will first need to know what are all the files that these users have, and once we know that, we can use the download file API to download all of them.
Okay, and then you have the sync function as well.
Yes, because say if we have we upload file in one device, and we need to know it in another device, so there should be some notification mechanism for the sync API. I'm thinking about maybe we can do pull, and maybe we can do push.
Okay. Any trade-off between pull and push, or do you want to decide now?
Yeah, maybe I feel like maybe we can defer that discussion for now, but we know we need some kind of sync API because I feel like maybe it will make sense we have some sort of higher level diagram drawn out now, and we can revisit this sync.
Yeah.
How do you feel about that?
Okay, sounds good. Sounds good. Yeah, we can continue and then we can come back.
Yeah, so first we have this API gateway, and then we definitely need some metadata server. So this is responsible for handling like all the metadata around file. And we also need like blog server that's actually handling the actual file storage. And we need, as mentioned, we need some notification service. It's responsible for synchronization. I'm thinking about that and do the notification, and then what happened? I think it will communicate with the client agent process. Yeah, I think, yeah, that's what I'm thinking on a high level. So the metadata servers, they will be responsible for handling the requests regarding a file, like for a user we need to know like the file directory, those should be stored there, and also like the file metadata, they should also go there. And then when dealing with the concrete IO of a specific file, we are trying to download the specific file. When we go through like the block store servers, like you will know like which file you are looking for downloading and what's the blob ID of that, and then the client agent process can talk directly to the blob storage for downloading or uploading the file. And for synchronization, there will be a notification service. So basically we know when we know there will be like a client upload one file on device A, and then we know that the API gateway will tell the notification service to notify all other devices that these clients have to start downloading of such a file, the new version of a file.
Yeah, that makes sense. So you have two arrows out of, back to the client agent process. What? How do they reach the client agent process? Yeah, the blob storage and also the notification service.
So Yeah, that's a good question. So for this notification service, so for Blob Store, like, the upload and download, say Blob Store is like, say if we use S3, the download can just be, HTTP link of a, a specific block. And then, for upload, we can use, some API provided by S3, like maybe like another HTTP request, like, you need to, send over a blob to the specific, URL. For notification,
so before we jump to the notification, so for that part, so initially I understood that the flow is the client service first go to the upper box, the metadata service, right, to upload something. And then it goes next. Does it return the flow back to the client, and the client service go to the block store server, or how does it? Yeah, can you tell me the sequence how this works, the life of an upload request?
I see. So yeah, so what happens is like, the client, when they upload the file, the client agent will know the file path, and you will divide it into multiple blocks.
Yeah.
And then you will, start uploading this file, and then it talks to the API gateway. It will go to metadata servers, and then here we will know we are starting to upload the file. So we will know there's a new file and what's the metadata for that file, and then the status is like pending. Like we haven't really, upload the file yet. And then we go to the Blob Store servers.
So what is the database schema? What type of database will we use here?
You mean for
the metadata? Yeah.
So we definitely have a user table, and we have a file table. Yeah, I mean, I guess it will dive into a lot of detail here because we definitely need multiple table. And I'm thinking like, given the the traffic we have, a relational database will be sufficient, and we will model them as like user and device and file. That's like the top one I'm thinking about right now.
Okay, and so we use a relational database. What's the trade-off? Why do we choose relational? What's the benefit? Are there any downside?
I think for this use case, I'm thinking, relational database will make more sense because, we do have, different, entities like, user, device, file, and those can be, modeled as a single table, and we can do, join between them to, to have, a relational view of, all the structure, and of, the files the user have, or, or the properties we need to know about. I guess because like, we only have like 2 files per day of upload for each user, really that's like, when we translate into, QPS, it's probably like, you know, 10 million times. Let me do a quick calculation here. Yeah, we only have like, you know, about, you know, 200 right QPS. That's like, you know, very moderate QPS that you know, relational database can handle. So I'm thinking like, you know, we can, you know, choose, you know, relational database over NoSQL or anything else for the, you know, benefit of, you know, like, you know, modeling the entities in a relational data model view, and also like, you know, the support of, you know, transactions.
Okay. So the two reasons you stated is the support for transaction and the relation. I mean, joining the tables together or a foreign key and all these.
Yeah. I think that the data model here just fits better with, you know, general, like, you know, traditional relational data model.
Okay.
And the QPS we are handling them without, you know, issue.
Okay. Okay, sounds good. Yeah. Any other table to add?
That's the top one I'm thinking about, and maybe like, you know, maybe there can be a block table, user device file block. I'm thinking maybe we can have another, you know, just to model the, you know, directory of a user. I haven't think about, you know, the schema, how it would look like.
Okay. Okay. And so the things you wrote down are the columns within the table.
Yeah.
Okay. So if a user has multiple devices, how will that store? How will the device? What will the devices field contain?
You know, it's like a list of, you know, device ID.
Okay. And you mentioned this is a relational database?
Yeah, it's a relational database.
Okay. And then the block ID of the file. Okay, list of file, the other is a list of device IDs. And then the file, we have file ID and the block ID. What would, is the block ID also a list or?
Yeah, it's also a list.
Okay. Okay, and what data type will you provide? I mean, will you assign these columns to have? So files, we can just take a few, the three that you wrote down as lists. What data types do we use for these lists?
Data type we use for this list?
Right, in the relational database.
So it's like, you know, array of strings, I guess.
Okay.
Because my previous job with Google, and the Spanner database we can use proto buffer in database schema actually. So it's like we can model off is like as proto buffer, but I would assume like say if we are using maybe MySQL or Postgres, we can model them use array of strings.
Okay, MySQL, Postgres. So they have an array. They support array. Is that right? Okay. Okay, sounds good. Yeah, so let's continue to the next thing. So the blob. So now we store this in the metadata database. The next thing is to upload the actual. So what happens next? The actual file content, I guess. How does the system work for the next step?
Yeah, so basically we write this metadata into the metadata database. We know like the status of file is switched to upload pending or something, and then we will go to the API gateway. We'll go to block store servers to know like what's the concrete URL that each block should go to.
Okay.
And then these will be returned to get URLs for each blocks, and those will be returned to client. And then client can start a connection to actually talk to blob store for directly uploading the file. We don't want to have those IO going through like this multiple hops, because we are transferring some concrete bytes. Like we don't want to waste our bandwidth on doing all of those. Instead, we would like to have a direct connection between the client process and blob store for
okay,
to do the upload.
So the blob storage, so there's a separate path to the blob storage. So a few things to clarify. For the second step, you mentioned the API. Is it the API gateway go to the blob store servers? So that it does not return from the client perspective. It's a single request, right? So the client will say, I want to upload something, and then it's up to the API gateway to talk to the metadata server first, and then the block store server second. So from a client, it's a single request. There's no returning back and itself called a block server.
Yes. So I think maybe we can clean up the API more, but the general idea I'm having is like we try to minimize those back and forth between clients and servers, but for those concrete IO when we are actually transferring, when uploading or downloading the files, when we are transferring those file bytes over the network, we would like to save the bandwidth. So we are trying to create a connection directly between the storage and the client.
Okay. So is that connection initiated by the blob storage or initiated by the client?
That's a good question. I'm thinking like I think both way can work with some trade-offs. One is like when we figure out like what's the URLs the client needs to upload, we can return it by the API gateway, and the client process will know, and it will do the upload from the to the returned URLs. the other way is like, the blob store can initiate a connection back to the client agent. I think I would probably go with the first way. Because I would like, those kind of logic, more unified in the agent process to,
Okay, so we go with the second way. So now the client, so do we need to change the diagram? So the client service has a, I guess, initiates a different connection to the server, and this time it may be to the blob storage. How does that change do you need to change your diagram? Since right now it's pointing from the blob storage to the client.
I see.
Yeah. Okay. And does it have its own, is it direct connection to blob storage? So blob storage, it sounds like has a port or something that's visible on the public internet that the client can connect to.
Yeah, so I guess it's more like, some concrete, URL to a specific blob.
Okay. So the client uploads it to the blob storage. After that, we completed the. Yeah, do we complete? Yeah. So what's after that? Yeah. So step number 5.
Once we have all the upload finished, the client will, just talk to the API gateway and just signal that we have finished.
Okay, so we signal that we have finished. So step number 5 is client signaling to API gateway. We have completed the upload. What does the API gateway do after receiving that acknowledgement?
It will. So the API gateway will, talk to metadata servers and mark the file as, uploaded, just to update the metadata of that, upload.
Okay.
And, the API gateway will also talk to the notification service. To do synchronization between other devices. That this user have.
Yeah, so how does it connect to, I guess you drew an arrow from the notification service back to the client. How does it establish that connection? Like what, how does it connect to those clients?
I guess that's like the first thing we deferred. We can do pull or push. I'm thinking 10 million daily active users. We can, one thing we can possibly do is like, for all the online device. So basically, some device can be offline. And, we probably, so that's like a defer from our current discussion, but we can have, some sort of, queue here. Oops. that's to, archive, some of the synchronization we should have done, but we couldn't do because the device is offline. And then, for the concrete connection, one thing is like, when every device gets online, they can have a long pull to the notification service. We just keep the connection open. The other way is like, maybe use some sort of, WebSocket. So, the client agent can, and the notification service can have like a bi-directional discussion.
Yeah.
So I think it may make more sense, like, the notification service. So once we have that connection open, basically like when there is a, update, and the API gateway will signal notification service, and notification service can connect back to, the client agent processes that it has connection with, and talk to them that, hey, here we have a new file, and you need to, start downloading it.
Okay, so they have a connection because the client, when it starts, it establishes the connection with the server.
Yes.
And then it holds on. So the connection is, long-lived, some type of long-lived connection. Okay. Yeah, and you mentioned long pull versus WebSocket. What are the pros and cons? Which one should we choose?
Maybe WebSocket, because we need. So just to clarify, I actually don't know deeper details between these two, but I think the key issue we need to address here is like, the notification service will need to be able to send a notification to the client when there's an update, and most of the time the connection can be idle, but when there is such an update, we need to have like a a near real-time notification.
Okay. And then after that notification, so in the notification, do we send the file content, or do we just notify that somehow the block has changed or something?
Yeah, we just notify the client that a file has changed, and then the client will do the download file, will initiate a download file API to the API gateway.
Okay.
One thing we can further optimize is that, say if we know it's only a block has changed, we can, only do like the download file API for some specific block instead of like the whole file.
Okay, makes sense. So we have 1 minute left. So in this diagram, if we have many users, then there may be many notification services, right? So imagine each box, maybe multiple servers for each of the boxes that you drew. How does the API gateway, so the client would connect to one of the notification servers, but there may be like 100 of them, or many of them. So how would the API gateway find the right one to send a notification?
I see. So because say we don't really have sharing between users, I think for the current model we have here, we can just do like some sort of sharding, like use consistent hashing or something, like to make sure like one client is always talking to the same metadata server or block store server or notification service. So it's like say we have that, and we can ensure like the sequence of operations.
Okay. So the sharding, so there's a based on the client, we will be able to locate the exact server to go to. Okay. Okay. All right. Thank you for the interview. So our time is up.
Yeah.
All right.
Thank you for interviewing with me today.
OK， 好，很感谢大家来参加我们的活动啊，然后现在请大家去给我们的考生打一下分数。OK， 我们今天是target level 4，so today we are going to target IC experience individual contributor level 4，so that's one level below the senior engineer. And then this is our form. So we provide 4 questions on soft skills and then 3 questions on hard skills. So for the soft skill, I can just read through so people can have some time to send in the score. If you have not seen this, the link is available on the YouTube chat window. So the first one, the soft skill, first one is gathering requirements. Second one is making decisions and justifying trade-offs. Third one is using clear presentation, concise language, and accurate technical terms. So for the first 3, rate the interviewee by comparing the interviewee with experienced IC near you. So in your own work environment, are there people who are experienced IC and one level below the senior, and how did the interviewee do in terms of the interview today? And then the 4th soft skill is driving the flow of the interview. So this is too aggressive or about right or too passive. And then there are 3 hard skills. First one, design quality, scalability, reliability, efficiency. Second one is basic facts about existing software solutions and hardware capabilities. And the third one is awareness of the project and product lifecycle in the larger context. Yeah, of course, if you have additional comments, feel free to put in here any suggestions for the interviewee how to improve, and also suggestion for our program. All right, so I will wait a little bit for the responses to come in. 然后今天很高兴也请到了我们的这个考生来我们现场，然后我们今天的是一个尝试一下新的形式，就是用这个 YouTube Live 的形式，这样的好处就是number one 就是考生在考试的时候没有那么大的压力，不会很多的观众在围观的时候在做这个考试然后 number two 就是我们可以就是有些紧急的情况，比如说这个出了些什么问题啊，或者是我可以加一些 subtitle 对吧？然后这些都可以事先 handle 一下另外呢就是我们的活动也可以录下来在这个 YouTube 上面这样子如果大家迟到了或者说还想要回顾一下之后再回顾一下，也可以到我们的 YouTube 上面去看我们的这个看我们这个活动的这个录像。对，很高兴大家能够今天来参加我们的活动然后之后我们也可能进一步改进我们的活动吧。然后这个 link 可能比我们之前的 Zoom， 我们之前是用 Zoom 来做这个活动的那 Zoom 的那个 survey 就比较容易填，不需要再点击到就是在 within the Zoom there's a survey link但是这个 Google Form 可能稍微难一些，所以现在 submit 的朋友少一些好，我们现在可以看一下这个 response。好，第一个是so the first one is gathering requirements。我们有11个 response，然后基本上都是 meets expectation， 对吧？然后有少数是exceed， 然后有一位就是有少数是 needs improvement。然后 second one 就是soft skill making decisions and justifying trade-offs， 这里面可能偏向于 needs improvement 吧。大家可以看到有就是一半的样子，但是needs improvement 稍微多一些。然后第三个就是这个 soft skill using clear presentation, concise language, and accurate technical terms。这里面我们就看到 多数的朋友就是打分是 meets expectation， 好，然后少数是 needs improvement， 所以总体来说这个 soft skill 还是做的不错的。好，下面我们是这个 hard skill， 我看看。还有一个是driving soft skill driving the flow of the interview， 多数的朋友都是打分是about right， 然后有2位是说 too passive。好，下面是这个 hard skill 部分，design quality， 然后好像一半一半的样子，对，现在就11位朋友，所以这个 margin of error 可能是一半一半的样子。然后就 needs 就是偏向于 needs improvement， 然后和 meets expectation 之间。好，然后下一个是 basic facts about existing software solutions and hardware capabilities， 是这个meets expectation 占多数。第3个是needs improvement， 对，这个是 hard skill awareness of project life cycle and larger context。这个是 needs improvement， 占多数，但是也基本上一半一半吧，就是 meets expectation 到 needs improvement 之间。好，很感谢大家的分数。然后这2个microphone volume is not stable， how about using a headset instead？ 对，这可能就是大家以后 interview， 所以在 interview 的时候可能调试一下这个 microphone， 事先调试一下 microphone。这样如果真实的 interview 的话，我们这只是一个节目，对吧？真实的 interview 可能这个 microphone 好一点是有帮助的。另外是 too many you know， 还有can deep dive into the database NoSQL versus SQL。好那非常感谢大家的建议。那我们今天也很高兴，考生也到了我们的现场。我现在先 stop share。那考生要不要聊一下，就是你对这个就是当时自己的表现有什么感觉？
喂 ，Hello， 能听到吗？
能听到。
OK，对，我现在刚 switch to AirPods， 我不知道麦克会不会好一点。其实我最近有做一些 interview， 然后今天就是自己看自己的这个直播才意识到，比如说麦克有很多问题，然后还有我说很多 you know， 其实我自己面试的时候我都没有意识到这个问题。可能因为就是之前 design 没怎么做过，之前都是 code interview， 然后这一次就是比如说遇到一个题，然后一边在做这个 interview 的时候，一边在想就是那个 design 应该是什么样，然后我就经常用了这种 you know 这种衔接词，但我确实刚刚自己听下来也意识到好像太多了，实际上起到了一个反效果。对，然后具体到 design 的话，我有看到大家提了很多很好的建议，有一些是我之前确实没有想到，可能就是自己知识储备然后各方面就是可能这个还要再花更多时间准备吧。然后对，可能大概先这样。
好，谢谢考生。好，那我现在 present 一下，就是我当时作为考官的感觉然后我们有一个活动的笔记是在我的这个 YouTube chat window 里面打出了我们的今天的笔记，大家可以跟我一起来看我们今天的笔记。实际上是昨天就是我和考生一起活动的时候录下来的时候做的一些笔记然后今天也又再听了一遍，又加了一些笔记。然后再就是这几方面吧，一开始是functional requirement，然后是这样，就是在 requirement gathering 的时候，我会想就是我从一个含糊的这个requirement 就是 design Google Drive， 然后我希望考生能够把我之前准备到这些 requirement 的点都能够问到那就证明考生是有一定的经验去来做这题的。那我觉得基本上我之前准备的就是 functional requirement、non-functional 都基本上能够 cover 到了，没有什么太大的问题。好traffic estimate， 我看看，对，然后对，我觉得这方面没有什么大的问题。我们可以就是直接跳到我觉得这里面有几个比较有疑问的地方就是我觉得总体来说这个图是 OK 的，就是这个设计，然后也是 可能是一个比较经典的题吧，所以这个大致的设计是 OK 的，就是有一个 metadata 的大一点，有一个 metadata 的 service，第一这上面是 metadata 对吧？然后中间这个是real data，然后第三个是 notification，然后我觉得这个大致是 OK 的，然后有观众问到为什么会有这个 notification service 对吧？在这里面也有一些疑问，在这个 chat window 里面，然后这里notification service 原因是我们想要 support multiple client for the same user， 就是有的大家说就是有的是这个 sharing between multiple users， 所以so when one user uploads a file, you want to notify the other users who also can see this directory, right? So when they're shared, there are multiple users. But on the other hand, if we have multiple clients for the same user, then when I upload file from one computer, I may want to see quickly, the changes propagated to other computers on my cell phone. So there's a reason for the notification service. So I think it's fine to have notification service here. 我觉得那个 trade off 可能就是说，如果那个 upload 的那个速度很慢，或者说多数情况下这个 notification service 没有什么 notification 过来，对吧？那there is resource consumption to maintain this connection, right? 所以就是说可能就是一个 trade off。如果我们觉得这个 update 并不是很频繁，我们不一定想要总是就是 maintain 这个 notification 的这个 link。但是那个 downside 呢downside is when there's a new change, then you may not be able to pick up that change very quickly. So there's some trade-off whether we have notification service or not. But 我觉得总体来说这个图是 OK 的。然后其中一个我在这里面写到了一些疑点呢，就是比如说 reverse 这里面有一个 arrow 是从这里有2个 arrow 对吧？然后考生是把这个 blob storage and notification service these two there's 2 arrows pointing to the client， 然后就这个跳跃性就有点大，就是说因为这里面是有一个 there's a some kind of load balancer in front and then there's a setup of servers, right？ 然后为什么会有一些 arrow 是跳过了这个 load balancer， 这一点我是比较疑惑的然后后面我就再追问过这个考生，对吧？然后大家可以看到这个blob storage 这里面就是可能是一个 logical flow 吧，有两方面呢，然后一方面这个 notification service 是一个 logical flow，是在通知这个 client， 但是真实的 implementation 是一个 long running 就是long running connection between the client and the notification service. So it's actually physically still implemented through a connection through the API gateway to the notification service, but logically there is this arrow. But a system design architecture, I found it a bit confusing to have this arrow not going through the API gateway. And then 还有另外一个是那个 blob storage， 有一个 arrow 对吧？然后后面就是考生把它换成了一个 arrow from这个 client to the blob storage， 这个是 OK 的。然后观众也提到了，就是说这里面可能有2种不同的设计方式。一种方式就是这个 the client does not directly talk to the blob storage, so yeah, the blobs the big binary storage, but going through the traffic can go through API gateway and to this block store server and then to the blob storage. So there's no arrow here, but the actual data is transmitted through this path. So 这个是一种设计的方式，对吧？然后另外一种设计的方式就是像考生当时说这个有一个 connection to the blob storage， 然后这边的 assumption 就是说我们假如用类似 Amazon S3 的这样的 service， 有一些这些 service 他们是自己有自己的 front end， 那但是这个 front end 就没有在这个图上表示出来了然后它有其中的一种方法就是说before you upload a file you talk to the blob storage to prepare an endpoint in its own blob storage front end, and then the connection can be established through some other mean to the directly to blob storage. 这是他们提供的一种功能，对吧？然后他们的trade off 可能就是说，如果 go through 这个 application 本身这个 path 更加 secure，但是 downside 就是说这个 traffic 会更大，就是more traffic will go through the application API server and this block and this application server, essentially the block store server. 所以有这两种的设计，然后我觉得这个是 OK 的 the design is fine. 然后另外还有一个疑问，就是在这里有一个 schema 的当时我截图还没有截好，是这里，就是this is the data schema，然后这个 data schema 里面考生这有两个疑问，对吧？然后是do we use relational database or NoSQL database? SQL database versus NoSQL. So given the queries per second, I think it is fine to use the relational. So the query per second, 有朋友在这里面问 QPS 到底是多少，对吧？这个 QPS 在我们的 requirement 里面没有直接 specify，我们的 requirement 里面说的是每天有2个 file 被 upload，就是 newly created, every user creates 2 new files every day，然后当然了，我们没有说到，就是也许考生也可以去 clarify， 就是 are there other files that are being updated, right? So if there's update to the file, then we may also need to upload the updated chunks to the server. So we can roughly, estimate based on the upload, the new file creation, and also the update rate. 然后考生当时的这个 estimate 是 based on only the new file creation， 然后有10个 million 的active users， 然后再除以，对吧？除以多少秒钟，每天多少秒钟，然后就说200多个 queries per second， 所以可能是在这个范围内的，所以就是说 relational database 如果我们 tune 的比较好，也许是 OK 的，可以用 relational database。当然，如果在更大的 QPS， 我们可以用 NoSQL。好，那这里面的疑问就是在这个relational database 里面，至少我之前的工作经验就是这个当你有 one to many relation 的时候，往往不会采用这个store an array at the parent table 这种形式，就是说一个 user 有 multiple devices， 对吧？然后一个 file multiple blocks。The usual way in relational database to store it, based on my understanding, is 在那个 child table, there's a pointer from the child table back to the parent table. So the block table should have a file ID pointer back to the file, but the file will not have, a list of block IDs. 然后这 user 有 devices， 对吧？然后那 devices usually it's designed as the device has a pointer back to the user。然后这种 design 呢设计就可以让individual records to be updated very easily, right? So if you just need to update one block, you don't need to retrieve everything from that file record and then insert, one block ID and then write the array back to the database. 然后the storage wise is also more scalable because each entry, if you have, a million blocks, you can just create like each block will just have, one additional entry for the file ID. But if you have a million block and you write all the block ID in the file, then the file record will be very large, a very large array of a million entries within the array. 所以如果用 relational database， 一般来说我们都会把这个 foreign key 放在这个 block 这边，然后这就是我的一些疑问吧，就是这对于这个设计来说，这个就是 architectural design 有一些，对吧？然后这个database 有一些这样的疑问另外呢，就是我可能会希望大家这个考生ideally 一步到位，对吧？然后就是少一些反复，比如说这边 arrow 掉头，一开始这个 arrow 是从这个 blob storage to the client device， 对吧？然后后面就把它调回来，再掉头画 从 client device 到这个 blob store，这样子就会有一些反复嘛。那我们本来可以预留一些时间去做这个 deep dive，比如说像刚才朋友提到 NoSQL versus SQL， 对吧？或者是 how do you scale the system if there are multiple of these services, right? So how do we find the right notification service to send the message to？ 那像这些问题，就是实际上就是说，这么回答就是我们这个顺序也没有什么错，对吧？但是就把这个时间给挤掉了，然后我们就没有办法去考虑这些 deep dive 的问题了。好，那这个就是我的这个想法。好，那我们再看一看，要不要回答一下观众的？我们可以看一看观众的问题，在这个 YouTube 的这个 chat window 里面。好，那也欢迎考生来说一下，就是这个看看观众有没有什么问题。不能直接接到 storage， 对，刚才就是213WF，这位朋友提到最好不能够直接接到 storage，security 可能有问题。这个我们就讨论过一下，这两种都是可行的，但是这个 security 可能是有一定的问题，就是如果是用一个直接接到那个 blob storage，那么他们解决的 blob storage， 他们解决的方法就是他们会有一个 short-lived URL，and also it's like a signed URL, so it's somewhat difficult to guess what the URL is, and given the time window that it may only be valid for, let's say, 5 minutes, right? So it's hard for an attacker to just upload to that block while this thing is, is open. But it's possible there's some security problem by directly connecting the client to the blob storage. 好，那下面看看 notification service 就多余。对，我们刚才也对，有2位朋友Elsa and David both said notification services is redundant or it's not doesn't need to be here。我们刚才也讨论了一下这个 notification service， 对吧？就是它的我觉得由于要 support 2个或多个的 client for the same user， notification service 在这里是 OK 的。但是它的可能真正的 trade off 就是说，这个假如 update is not very frequent， then we probably will waste some resource by keeping a long running connection with the notification service, if its update is very rare， 所以可能有一些这样的 trade off。好，然后在下面看看 soft skill。然后 QPS 是多少？题目是不是提前告知？对，题目还是就是大致的方向是还是提前告知了的。然后还有就是，请问老师，如果您因为system design 轮把人挂掉，是不是因为连图都没有画出来，还是有别的最低的标准？我觉得是这样，就是最低的标准是要有一个 working design， 对吧？就是如果它 it doesn't work， 那就肯定要挂掉了。但是如果在最低标准以上，对吧？然后大家都有 working solution， 那么我们可能就会把考生分为几种类型，然后一个是我想可能有2个方面吧，一个就是大致就是说考生会互相 compare。I have a pool of interviewers, right? So how do I pick the best ones, right? 然后可能就是一个是努力的考生，对吧？然后一部分是能够 innovative can solve new problem 的考生。那如果我们这两个指标都就是有的考生是努力的就是说我怎么看出他努力呢？就是他对于这个问题还相对来说比较熟悉，能够把东西问题问到就是可能一步到位或者什么的，他可能是准备过做一些准备的。那这些考生可能是比较努力的，因为他们去刷过题，对吧？但是当这种考生出现的时候，我可能就会追问一些问题，就是比如 storage system 一些细节，对吧？然后怎样这个 sign 的 URL 或者怎样子，对吧？那可能就遇上一些新的问题。是不是能够 solve the new problems， 对吧？然后还有另外一种，就是说他可能没有见过这道题，但是他通过这个 first principle， 他知道系统设计有这些步骤，他能够 自己把这个系统在没有提前准备的情况下能够设计出来，哎，那我觉得这种也不错，对吧？那当然最好的就是既努力了又能够有 innovative solution 的 ，OK， 它一步到位，而且你深究的时候，它能够通过你的新出来的一些 unexpected question 来回答到，就是说能够给你一个满意的答案，那么那可能是最好的这样的考生是最好的，对，所以可能就这两个 dimension。好，然后还有什么呢 ？Version difference between coupled devices。好，那我在想，考生要不要来回答一些问题？就是刚才你可能也看了一下这个 YouTube 的这些观众提问。
可以啊，是具体哪个问题呢？
好，这里面有可能 version difference between coupled devices。我想这个问题可能是，如果2个 device 同时 update 同一个 file， 那可能就会有出现问题，对吧？
对，这个就是我记得我们这个题目就是说我们只要 keep latest version 吧，然后就是可能具体 design 的时候，就是比如说你 initiate 一个 upload file 的这个过程，然后我们首先是它会 write 到那个 metadata database， 就是说我们现在有一个 upload file 的一个 process， 然后它有一个 status 会 change to pending 这样子，然后我们就可以按这个顺序，我们可以知道就是哪一个 request 是先来的。我不知道是不是他问的是这个问题。
对，魏然要不要就是对，如果是回答到的答 OK 对吧？如果没有，可以 clarify 一下什么问题。对，这里面我们的 requirement 就是save the latest version 但是就是说如果是要考虑 version， 可能是有一些就是 raise condition。好，那解决的方法就是可能可以 save multiple version， 可能可以 rename the file， 对吧？就假如正好1秒钟内同一个 file 被两个不同的 client 都 update 了，对吧？那可能就是说有一些处理的方法。假如我们能够留存 both versions， 或者把这个名字改一下，对吧？在一个地方加一个后缀或者什么，就改成2个 file。好，然后下面是不是 metadata storage 用 relational database， but blob storage use SQL NoSQL。好，那考生要不要回答一下？
对，我这个 design 就是 metadata storage 就是 relational database， 然后 blob store 我们肯定不会用 relational database 来存吧，就是因为我们是存具体那个序列化的文件的 I/O 嘛，然后就是我提到的是可能就是类似于 S3 这种 file storage。
好，那再看看 conditional update， 213WF， 我不是很清楚这个问题是什么是 conditional update。然后下面还有一个问题，正常登录 client 的时候，是不是会获取一个 list of files， 然后显示在用户端？那这时候client 上传了文件之后，另外一个 client 登录的时候，是不是也会 query 一下 file list？那就能够拿到最新的file 的数据，还是需要通过 notification server？ 好，那考生有没有什么想法？就是new file getting created, a new files getting deleted, right? So if the file list changes, how does that propagate to a different client？
就是他这边这个提到的是说，我们每次登录到拿到了 file list， 但是就是比如说我们这个一直是 online 的时候，就是比如说你在一个 device 上修改了一个 file， 然后你肯定需要同步到其他的 device， 尽量是 real time。然后这个时候就是我对 design 就是想的是有一个这样 notification service， 然后它会负责就是通知，就是比如说在 device A 上面我们 upload 一个 file， 然后会通知剩下的 device B、C、D， 然后就是说这里有一个新 file， 你们需要call 那个 download file API 去更新这个 file， 这样子。 就它不只是在登录的那个步骤嘛，而是你在线的时候，然后你一直需要有一个这个接近实时的更新。
好，所以就是可能就两种情况，对吧？就是一种是离线又登录的情况，然后另外一种是 already online 的情况，然后这两种情况都有办法处理。好，我看看还有没有其他的问题这里面说是不是 push model？
对，就是因为这种 change 可能比较少，然后应该是由 notification service， 就是建立完这个连接以后 notification service 去主动的告知，就是说其他在线的这个 device。
对，好，所以这算成是一个 push model， 然后可能会有一个这个是 pull 的 backup， 对吧？假如你们离线了以后，那可能还得 pull， 就是假如没有 connection。好，然后还有至如朋友问 AWS SQS， 不是很清楚，具体的问题是什么？好，然后下面是 feel better for push, do not hear the discussion for push versus pull in the interview unless I missed it。对，好像考生你记不记得我们好像没有讨论这个是不是需要用这个 push 的这个就是 notification server 是不是需要存在的这个问题？
就是当时有说到一些具体的，可能我因为就是当时不有提到，比如说可以用 loop polling 或者是 WebSocket 之类的，然后我可能对就是这个具体实现细节也不是特别了解，然后当时我就说就是我的 key idea 就是说是由 notification service 来主动的，就是说把这个change push 给那个 client instead of client 就是反复的轮询。
OK，好，对，所以 David 朋友的问题问得很好，我们这里面好像是没有特别讨论这个 trade off，就是特别是 push versus pull 的这样的 trade off。好，下面是离线就直接 query of list of file， 对好，下一个问题是民同学问的，我的理解是离线登录就直接走 query list of file 了，如果是有 online 的 client， 就是 push 到 client， 然后 client 自主更新 query 一遍 file list。对，考生觉得这个设计对不对？
可能都可以吧，就是离线登录可能就是可以 query 一下，就是直接知道有哪些要更新。然后我可能当时面试的时候，我想的是就是可能 notification service 还会 keep 一个这样的 queue，就是我觉得可能都可以，就是因为如果你是离线登录，如果有一个 separate 的这样的一个 workflow，我不知道就是我当时想的是，因为我们就是有 one way of doing things， 然后就是说我们需要 notification， 然后不管它是离线登录还是 online 一直 online， 就是我们都是走同样的一个 workflow， 可能会把系统更简化一点但是你也可以就是说我们离线登录的时候，我们就直接就是 query list of files， 然后一下就知道有哪些 change， 可能也可以。
OK， 所以你的设计是离线，你想用同一套code， 然后 ideally 从这个 client 的角度来说，登录之后马上又收到这个 notification service 的一堆的 notification， 对吧？然后就说，哎，这个变了，这个变了，这个变了，希望这样子，我们就不用写两套的这个 code 在这个 client 那边，只需要 head notification 就可以了
而且因为就是比如说你要是你真的它有很多文件的话，然后你每一次登录你需要把整个 structure 重新 diff 一遍，我不知道那个效率怎么样。就是对，然后刚才提到的确实就是可能 one way of doing things， 我感觉可能会更合适一点，但这个可能也是有 trade off 吧。
好的。那在你的设计里面，怎样能够达到 这个 notification 对，我不是特别清楚这个 offline queue，how does it work？ 然后能够使这个用户再重新连线的时候，这个 notification service 又能够 push 这些 notification 过去。
就是notification service， 它知道它需要通知这些 device， 然后就有这些 change， 然后它可以放到一个 offline queue 里面，然后就是因为现在没有连接嘛，然后等到比如说它在另外一个 device 登录了，然后就会建立一个到 notification service 的连接，然后这个时候我们就可以把 queue 里面就是还没有完成的这些需要 update 的这个 work item 取出来，然后就是都发给那个新登录这个 client agent process。
OK， 好的，那就是说我们如果事先知道有3个 client 在，对吧？然后但是第3个 client 没有上线，那么我们就通知了其中2个 client， 然后第3个 client 的那些 message 放到了那个 queue 里面去，然后第3个 client 在登录的时候，我们又从那个 queue 里面登录那一下可能 trigger notification service 去 pull from the queue for the third client。
对，大概是这个思路。
OK， 那如果我们有好多个 client， 那是不是同一个 notification 需要好几个 message in the queue？
对，就是可能这可能也涉及到这个具体 schema 什么 design 吧。就是它可能会有一个 version 或者 timestamp 之类的设计。就是说我们可以知道这个 device 就是它是从哪一个 version 之后的更新它都没有做过，就是它可能不一定是这样的一个 queue， 或者是就是它能够记录下来一个这样的一个日志一样的东西，然后就有一个 sequence of operation， 然后每一次这个 device 登录，我们知道它最后一次是到了哪一个 version， 然后接下来都是它需要就是 replay 的那种感觉。
OK， 那如果比如说我有3台电脑，然后其中2台都是 offline， 对吧？然后我第3台我正在更新一些文件，那么由于有2台 offline， 假如我更新了1个文件，那么可能会需要存2个 message， 一个是给 first client， 一个是给 second client， 这2个 message 里面的 content 都是说这个 file 被改动。
对，就是我感觉好像现在又重新继续在这个面试。对，我想的就是这是2种方案嘛，就是你那个 schema design 的时候，你是需要比如说 user 和比如说device 都在那个 key 里面，还是说你是想就是比如说对于一个 same user， 它就是一系列的操作，然后它会每一个操作它比如说有一个它是 sequence 的嘛，然后你会知道它就是操作到每个 device 它停在了哪一个 version， 就是你在这个日志里面你是到了哪一个步骤，然后这样子的话我们就不需要 duplicate message for multiple device， 就是我们只需要知道这个 device 它上一次更新它是到了哪一个步骤了，然后接下来之后的改动它都需要按顺序都做过去。
好的，对。然后有朋友213WF，他提到的可能就是像 Kafka 的这样的 service， 可以存一段时间的这个，就是说可能有的 client 老是不上线，或者他的电脑坏掉了，那就永远都得存下去，可能是有一定的问题。另外就是 Kafka 里面同一个 message 可以被deliver multiple times， 可能就是有一个 可能有 consumer group 的这样的 concept， 对吧？就是只需要发一个 message， 但是不同的 client 有自己的 watermark， 所以它可以分别的去消费这些 message， 然后不需要同一个 message 被 replicate multiple times。对，所以这个可能是值得考虑的一个方面，就是说 offline 怎样去处理。当然还有一个就是说那个 new client， 对吧？那 new client 从来没出来过的，他需要第一次要把那个文件下载下来，他可能就是还是有一节的 code 需要去 pull the message。当然他 new client 也可以去 replay 那个 message queue， 但是可能这样的设计会有点奇怪，原因就是假如一个文件被改动了好几次，那么一个新的 client 来了，它实际上可能只需要最后一个 version 就行了。但是我们通过这种 replay 的方式，就可能会把中间的一些 version replay 完了之后，再就是改写，最后改到最后的 version，有可能还是做一些pull 的工作会某些情况下可能更 efficient 一些。好，然后下面有朋友 Justin 问了，这样的话是有个 device 很久不登录，有很多 activity 需要巨大的 queue，存所有。对，就是假如有一个，我觉得如果有一个电脑坏了，再也不登录了，对吧？那我不知道这个 queue 要保存多大。对，我不知道考生也可以来，就是说回答一下这个问题 ，Justin 的最后一个问题。
我想的是，比如说这个日志太久以前的可以合并嘛，就是对于同一个 file 的就多次更新，我们肯定只需要留它的最后一次就好了。然后，对，就是如果我们是那种 replay 的方式，那它可能就我们说是一个 queue，但它实际上更像一个其实是一种那种 persistent 的 storage， 然后就是确实需要一直存，但我不知道，应该也不算很大的问题吧。
好的，对，所以就是说有可能可以永远就当一个 persistent， 就是一个 change log for the file，或者是 collapse 那个，就是说把它合并一下，反正最后一个 version 是最重要，就是我其实只需要最后一个 version， 所以可能前面的可以丢掉。对，好，那我们看看还有没有其他的朋友有问题。好，好像基本上没有问题了。你看，对，好，那很感谢大家来我们的活动。如果希望对，也欢迎大家去订阅我们的频道，然后之后可以参加这个 chat 的讨论。另外就是如果想要加入我们以后的活动，还没有入我们群的话，可以扫码加我们的工作人员，然后联系好了之后可以告诉工作人员你想要进这个系统设计的群。对，然后另外就是我们也希望大家能够来做这个system design interview，然后我现在就是改了一下这个形式啊，所以因为最近找工作的朋友比较多，如果大家想要用这个形式来做的话，我们不一定要等到星期天，对吧？如果比如说大家急着要interview 的话，我们可以先 interview 之后再把它录下来，然后在星期天的时候再跟大家一起讨论。那么可以提前做一些mock interview 那也欢迎联系我们。那如果如果能够和其他的朋友一起分享那么我们就做一个免费的这个 interview， 对吧？然后最后跟大家去讨论一下如果说比较希望 private 和比较快的得到这个服务的话，也欢迎联系我们这1对1的这个服务。好，那非常感谢考生来跟我们做这个 interview，和花时间和大家一起讨论也非常感谢我们今天的观众来我们的频道做这个直播的活动那么我们就下次再见谢谢大家。